Good morning. My name is Karine Habshi, and I'm going to give you the dynamics course. So first, I will just introduce how the course will be divided on Moodle. You can access all the material will go over together through Moodle. You have several sections in Moodle. So first, you have the syllabus of this course. In this course, we will deal with dynamics of a particle and a rigid body. Now we will introduce in a while what is the difference between a particle and a rigid body. For the course material, it's divided into several chapters. So first we will start to deal with a particle. So let us talk first, what is the difference between a particle and a rigid body? Uh, in general, whenever I say I can treat a body as a particle, this means that I can neglect its dimensions. So if we consider that I can treat it as a point, then it's a particle. And sometimes even let's say you have a car, you can treat it as a particle in certain problems, while in other problems you will need to treat it as a rigid body. We will learn together when we can do the assumption of a particle and when we cannot do it. Okay, so let us just do some illustration of this. I will open a new folder. Okay, so if I consider, let's say, a small ball of tennis, for example, and I want to study how it's moving in air. I give it a certain velocity, and I want to study its path, for example. This is a very simple example, okay? I can say that the dimensions of these particles are small enough and so that they will not affect its motion. And then I can just consider its weight and study the effect of its weight on its trajectory. Okay, so in this case, I'm treating it as a particle. Now, sometimes even if I have a car, let's say that is in static case, it's not moving, for example, and I want to study its equilibrium. Okay, then in this case I have forces at different points of my car. So I have, let's say, its weight, I have the normal at each wheel. Okay, now here the modeling as a particle can work. Why? Because I can consider that these two forces, for example, because of symmetry effects, I can consider that I can replace them by one resultant force, for example, and then I can deal with it as a particle. So even if the dimensions are large in certain cases, I can treat it as a particle for specific conditions. Now, when my car is moving and my wheels will do rotation while the body of my car will undergo translation, then I should deal with different parts, okay? And I should consider it as a rigid body. I cannot neglect anymore its dimensions. So the first part of this course will deal with dynamics of a particle. We will neglect the dimensions and volume, and of course we'll just consider the mass. So we can treat a body as a point with a certain mass but with negligible volume. So this is then the definition of a particle. Okay, now whenever I deal with a particle, it will be much simpler than for a rigid body, because we'll see together that whenever dimensions are introduced, when you want to study, for example, Newton law, for a particle to study Newton law, you just say sum of forces equal to the mass of this particle times the acceleration of the point, which is represented by G, which is the center of gravity. While if you consider a rigid body, this is not enough. Okay, for a rigid body, we should add another equation. We should add the rotation, for example. So here, let's say we'll divide the car into several parts, the body, the wheels, and for each part, we should write the equation of motion. And whenever I have a rigid body, I have the addition of an equation, which is sum of moment about G equals to IG, which is the inertia, times R. So this is a small definition of the difference between a particle and a rigid body. Okay, so now for the first chapters 12, 13, 14, and 15, we will deal with a particle. Now, what are the topics that will be covered? First, we will start with kinematics of a particle. What is kinematics? Kinematics is the science which will study relation between time, position, velocity, and acceleration without considering forces acting on the particle. Okay, so if I'm just interested to know the path of motion and its characteristic, what is the position function of time, what is the velocity function of time, what is a function of time or function of position. So we will see together that you can express, for example, the velocity or function of position or function of time. And we have differential equations that relate these variables. So when we are interested in studying the relation of these variables with respect to each other, then we are working in kinematics and we don't consider forces. Of course, forces will affect the kinematics because you know that acceleration is directly related to forces through Newton's law. So some of forces acting on, if we are treating, we are dealing with the particle, we'll just have Newton's law, sum of forces equal m times hg, which is the Newton's law of translation. We don't write the Newton's law of rotation because it's not a rigid body. So in this case, when we move to the relation between forces and acceleration, then we are moving to the topic of kinetics of a particle. Of course, these topics are very related, but for educational purposes, they divide them. But in any problem you will have to solve, you will need to combine these two ideas. And in general, in many problems, the first step you do is to draw your body and consider all forces acting on it. And this step is called to draw the free body diagram, FBD, free body diagram, which represents all forces acting on your system. So if we go back to the simple example of the tennis ball that is projected in the air, you just have the effect of the weight. So, and you can neglect resistance of air. So this is your free body diagram. Now, if you write a Newton law on it, what do you get? If I consider my y-axis upward, then if I have that sum of forces along y is equal to minus w, and this is equal to the mass of my particle times its acceleration in y. So you can deduce from this relation what is ay, because the weight can be written as mass times g. So I deduce that ay is equal to minus g.